Hello, I'm Nathan Anconi, machine learning engineer, AI developer, programmer, among other things. And I've been wanting to do sort of a breakdown or overview of this project I've been working on, the Codebase, for a while because um, I'm pretty proud of it and I've been sort of promoting it, but it's not very accessible. Um, and I do believe in it. But I've recently basically done a pretty major refactor that put it in a state where I think it deserves uh, kind of, or it is more accessible. So I just wanted to sort of give a high level view of how the code base is architected because as much as I've attempted to document everything, it's kind of a far out idea, and unless I show people what I'm talking about, they're probably not going to understand me. Anyways, just for a quick uh, overview, it's basically you can watch a video where I give a presentation on this idea from a more sort of conceptual level. Basically, what I'm trying to do is, unbox the black box or untie the cat's cradle of artificial neural networks. I I think a lot of explainable AI projects essentially look at it the wrong way. That they need to look at it more like less about how do we sort of track metrics about the model. We have to focus more on the model itself. Sort of modeling the model, just like a brain scan, basically. Sort of reconstructing the model from the inside out and basically associating different areas of activity with model states and basically just sorting through these matrices of numbers, okay, and finding the structures in them. And I believe this is doable, and I'm sort of on this one man mission to prove it. Anyways, so like I said, um, the code base is very abstracted and encapsulated right now. And I realized that I essentially have discovered in the course of working on this project just sort of an excellent way to do PyTorch. Um, Even if you're not interested in all the sort of visualizations that everything amounts to, I've sort of inadvertently, in the course of trying to find the best way to kind of record these models, um, I kind of just created a really cool way, like a cool pipeline for just creating models and to uploading models. So everything basically circles around this traceable pipeline, and we're going to basically walk through the stages, the steps of what goes into this pipeline, and then we're going to talk about how that all comes together. And I'm not going to break everything down to extreme, excruciating detail because we'd be here for 2 hours. But you can basically assume that the high level abstractions, the encapsulations, are going to stay the same, even if you know, a lot of the details get changed around. So, really, the first part of it is this data handler class, and this is where you are loading in data for the model that you want to trace. So, currently, it only supports synthetic data. I'm going to need to add uh, well, it has the the iris data set, like the classic machine learning data set, which is I used as my kind of base, my sort of test my sort of guinea pig model. But the idea behind this data handler is that it basically allows you to load in whatever model you want, ideally, and do basically standard pre-processing. Okay, so you know, there's a lot of variety. I wanted to make this system as generalizable as possible, but the configuration space of possible models is probably way more than the atoms in the universe. So I'm trying to sort of cover all of them, though, as many as possible. So I'm not going to break everything down here. It's pretty annotated, but you're going to do a lot of standard data pre-processing. You can specify what scalar you want, and then this comes over to model configurations, and this is like sort of a neat modular way to encapsulate all of the parameters, the hyperparameters that you might put into a model. And here I have a generic example and one for the iris data set. And here I'm loading in those data loaders that are set up over here. And we're basically putting everything the model needs for training and inference onto this config. And then we have this configurator that kind of further decorates certain classes of model types. There are certain recipes that, for binary classification, you're going to want a sigmoid activation function for outputs. You're going to want cross entropy loss for multi-classification. And, again, I'm trying to sort of cover as many sort of commonalities as possible, but there's also the option to provide your own custom configuration here. So this model configurator class works with this model configuration and works with the data handler, and now you have a neat sort of package for your. And that brings us to, what does it bring us to? It brings us to traceable model. And so this is basically what all of that eventually gets injected into. This is basically going to connect the model to our tracing logic, and this will basically, it uses hooks to basically watch an observer pattern, to watch different states, different layers of the model. You can kind of specify where it can switch between training and inference. So if you want to like test out a already trained up pre-trained model, you can do that. And that's really important for like recording activations. You don't really need to record activations during training. And so yeah, you basically have different modes, and you're tracing basically the internal states of the model, and so that will bring us probably to this class is these two classes. So neuron trace and network trace. Now this is sort of the beating heart of the whole project, and I've gone through a billion different iterations of this, and I've kind of refined it to a point where I think it's fairly satisfactory, but who knows, I might kind of throw it all away. But basically, the neuron trace represents a single neuron in the model, okay? And it's going to capture the states of that neuron and sort of represent it in a data structure, okay? And network trace is going to represent sort of the layers where these neurons are going to sit on. And it basically will provide us with a framework, a skeleton, by which to sort of map the neurons and to sort of abstractly reconstruct the network in a data object. And I used to have one single kind of endpoint for a data frame, and I used to cast the data frame separately. But now I have these methods where you're sort of able to cast it into different types of data frame depending on what your use case is. So if you want to model graphs, do it this way. If you just want to kind of crunch numbers, do it this way. And so more or less that'll bring us to the pipeline. And this is where it all comes together, okay? So you can see I'm importing all of those goodies, and we're basically just setting everything up here, setting up the configuration. We got the training loop. We have different operations depending on what your loss function is. Again, probably not covering all the bases, but this can keep being extended. You get the evaluation method for a test data set. Again, trying to cover lots of bases. And the details here might, again, switch. And then you have, a method to kind of save the results and print it out, and or write it to an output directory. And then that'll take us to main.py, which basically is just going to run very simple. All of that, you're just passing in, you're initializing a traceable pipeline, you're setting up you're passing in your model, you're passing in your configuration, you're passing in what data set type you want, and you train the model, and then you save the results. Basically, the results will go to here, and we have to the network trace kind of has to be exported separately for reasons. And then all of this essentially comes together in analysis, this Jupyter notebook here. And this is I finally gotten to the point where I actually, the real work begins. So, I'm also, by the way, going to assume that people using this project are like learning practitioners and know how to set up an environment like this. Very standard, simple environment, Conda. Some the usability here is going to be limited to people who understand it, but everyone can appreciate the pictures, I hope. So anyways, um, I'm running the process, main.py, and here I'm just you can see what you're going to get. Since this isn't training, we're not actually going to get activation data. We're going to get other types of data though. And when we're basically organizing it so that eventually we can start. Here's kind of a 3D. This is just kind of like a first attempt at modeling the model, and this one is actually, I think, pretty cool. So you can kind of see the Sankey, how it's, the model is basically being reconstructed. You're getting this sort of cat's cradle looking design here, very pretty. And some of them are, I'm just playing around here, but this is another way and to look at it. And this one, just whatever, it's a mess, don't even bother. But and what we're doing here is, these are connections. You can sort of filter out the strong connections, and still all a work in progress here. But so what I'm basically building up to do though is find the right mathematical techniques for finding patterns, predict, in different states, is the model in a different state, an identifiable state when, it, for that inference batch, it detects a particular output and it's correct, What does it look like? Is it in a rate? Can we isolate these numbers? Do you see what I'm getting at here? Can you break it down? And I think, there's some pretty difficult math going on in there. And but we're getting to the point, I'm getting to the point where, I genuinely think we can start piecing together, what these models are doing. And no more black box. Like, there's problems with scale. I've been trying to make this more scalable. That's what all this is about. But there's some spaghetti in here. Like this, this code is probably, it's going to continue needing to be refined. But we're getting to that point. I think I'm getting to that point where we're going to be able to, actually kind of reconstruct what's going on and associate different states of the models with different outputs. And this has all kinds of benefits and advantages, I think. So anyways, yeah, that's my moonshot project. Hopefully this has made it a bit more accessible to people. And if you're interested and you want to reach out, look me up on LinkedIn or something. I don't know. I'm like, but yeah, I think it's pretty cool. And even if you're not interested in this sort of analysis and stuff, this pipeline that I came up with is like a really like, you know, I sort of inadvertently landed on this way of sort of just doing uh, machine learning model like development, where everything just kind of fell into place. So, you know, even if you're not interested in this part, you know, everything else, it's a good, I think, starting point just for thinking about um, PyTorch and these models and setting everything up. So, yeah.